Alright, welcome back to our Calculus 3 class notes, everyone. We're in section 15.8, the last section of chapter 15, and we're going to discuss example 96 here, where we're looking at transforming a double integral with respect to y and x into a new integral by using substitution, where the integral is with respect to u and v now. Okay, so here's the region R sketched over the xy plane, right? So as x is going from 0 to 1, y is going from the function y equals 0 to the function y equals 1 minus x. So this is the region R. Now I actually need to figure out what's the region G in the UV plane that we're going to integrate with respect to the region over that we're going to integrate with respect to. But technically what I need to figure out is what is x in terms of some function of u and v, and what is y in terms of some function of u and v. But I do that by saying, okay, I look up here and I say, well, what makes kind of a recognizable two substitutions? I need to find one for u and one for v. So it seems to me when I look at this that if I let u equal x plus y and I let v equal y minus 2x, we might get something that works. Now again, with substitution, you never know. You have to work through it and see if it's going to work, but I think that will work here. So I'm going to do that. I'm going to let u equal x plus y, and so v equals y minus 2x. Now I need to solve that system of equations in terms of x and to get x equals and y equals in terms of u and v. That would be my functions g and h. So look at this as a system of two equations and two unknowns. I have x plus y equals u, and I have minus 2x plus y equals v. So I'm going to subtract this second equation to get rid of the y's. So that gives me x plus 2x, which is 3x, equals u minus v. So x equals u minus v divided by 3. Then I take that, I'm going to substitute it back into this first equation. So u minus v over 3 plus y equals u. So y equals u minus v over 3. So that's 1u minus a third u, so that's 2/3 u. And then minus and minus is plus 1/3 v, or 2u plus v all divided by 3. So there's x and y. Now I want to make my boundaries be transformed. So these are the boundaries of the region R, right? Remember we had x equals 0 going to x equals 1, but when I just look at it right now, we have three boundaries, right? We have the boundary y equals 1 minus x. We have the boundary y equals 0. So then this boundary here is x equals 0. So there's three boundaries that I need to transform. So y equals 0 is the same as 2u plus v over 3 equals 0. So that's 2u plus v equals 0, or v equals minus 2u. And then when I have y equal 1 minus x, that's the same as 2u plus v over 3 equals 1 minus u minus v over 3. So this is 2/3 u, and this is minus 1/3 u, so I'm going to bring it over here, and that gives me u. Then I have 1. Then this is 1/3 v, subtracting 1/3 v, so I just end up with u equals 1. There's u equals 1. And then x equals 0 is the last boundary to work on. So that's u minus v over 3 equals 0, which is the same as u minus v equals 0, or v equals u. So here I have my three boundaries. So I'm going to plot those in the G to find G in the UV plane. So v equals minus 2u is a line with a slope of minus 2 going through the origin of the UV plane. U equals 1 is this vertical line dropping through the u axis at 1. And v equals u is this 45-degree angle line, just like y equals x, right? So we have v equals u. So this then is the region G. I didn't color it in my notes like I usually do, but this in here inside this triangle is the region G. The last thing then that I need to do is go ahead and find the Jacobian of the transformation. So remember that's this 2 by 2 determinant. So I need the partial with respect to u of x, which is u minus v over 3, so that's 1/3. Partial with respect to v of x, so that's u minus v over 3, so that's with respect to v, I get minus 1/3. Then I need partial with respect to y of u. So then here's y, take the partial with respect to u, I get 2/3. Here's y, need the partial with respect to v, I get 1/3. So I get 1/9 minus a minus, or plus 2/9, which is a third. So this integral, which I start off with, which we actually could not evaluate now, is transformed into an integral which we can evaluate. So u is going from 0 to 1, and v is going from minus 2u to u. When I look at this, right, as u goes from 0 to 1, v goes from the function minus 2u to the function u. So those are my limits of integration. And then remember, we let u equal x plus y, which, whoops, I'm sorry, right here. We let u equal x plus y, so that's u to the 1/2, and we let v equal y minus 2x, so that's v squared, times the absolute value of the Jacobian, which is a third. I'm going to bring that 1/3 out, and now I have a very simple integral to integrate. So first I integrate with respect to v, leave the u to the 1/2 alone, and I get 1/3 v cubed, evaluated from minus 2u to u. So I'll just bring out the 1/3 first. That gives me 1/9. Okay, evaluating u is u cubed minus evaluating at minus 2u is plus 8u cubed. So that's 9u cubed divided by 9 just becomes u cubed. U cubed times u to the 1/2 is u to the 7/2. So I now have the integral from 0 to 1 of u to the 7/2, which is 2/9 u to the 9/2, evaluated from 0 to 1, which gives me 2/9 as my answer.